All right, 9.1. So chapter 9, we are talking about hypothesis tests. So let's start with what a null hypothesis is. So a null hypothesis is going to be notated by H sub 0. Okay, so it's H0 or HO. That is a claim about the population that is presumed true until proven otherwise. So a claim about a population that is presumed true until proven otherwise. Okay, so that's your null hypothesis. And then you have an alternative hypothesis, which is typically given and notated by H sub 1 as an alternative, okay? And the alternative hypothesis is just the opposite of this. So what if this is not true, or if this is proven false, then the alternative hypothesis is true. So this will be true, or will be presumed true. Okay, if the null is false. All right, so when we are doing this test, you have 3 possibilities, which we'll look at a chart for these shortly. The first possibility is that your test is correct. And then the other 2 possibilities are that you get an error. And there's 2 types of errors. So you have a false positive, which is called a type 1 error. Or a false negative. Type 2 error. Okay, so a false positive, let's say you take a COVID test, it comes back positive, but you don't really have COVID. That's a type 1 error. Take a COVID test, it comes back negative, but you really do have it. That's a type 2 error. You have types of tests here. Your test is always going to go based off of the alternative hypothesis. Okay, so what type of test you're doing will be based off of the alternative hypothesis. And when we say tails, we are talking about normal distribution. Okay, actually, let me draw this over here. So a two-tailed test, okay, that is going to be equal or not equal. So you have 2 tails with a rejection region in both tails. So you just draw this real small here. 2-tailed test, 1 on either side. Okay, you have a left-tailed test where the alternative hypothesis points to the left. So that would be the left side is highlighted. And then a right-tailed test, the alternative hypothesis points to the right. Right side is highlighted. All right, so when we do a hypothesis test, we use weird wording. We are not going to say true or false. We're going to say we're either going to reject the null or failure to reject the null. Okay, so that means rejecting the null means the null hypothesis is false. Okay, so when the null is false. Okay, we assume that H1 is true, the alternative. Okay, the rejection region is going to be the region where the null is rejected, which are these highlighted regions up here. oh, I don't know why I just wrote that, region where, sorry, null is rejected. The critical point is the value that will cause rejection. Okay, we'll do some examples with these, but the critical point is, let's say the critical point is 2 and you get 2.1, that would cause rejection, depending on the rejection region. All right, the alpha region, that is your rejection region. So again, this highlighted region is called your alpha region. The significance level, so the significance level is the probability of making a type 1 error. Okay, so let's look at this. So for example, for 5%, the critical z-score for a one-tailed test is what? And for a two-tailed test is what? Okay, so let's look at one tail first. So let's just say this is left-tailed, all right? If it is a left-tailed test, then that means that in the rejection region, I have 0.05, so an area of 0.05. Okay, which means I would need a z value for 0.05 in this region here. Okay, so if we recall, for the z value, we have two choices. We can go look at the chart, okay, or we can go to our calculator. We can go to second distribution, inverse norm, area to the left, 0.05, a mean of 0, and a standard deviation of 1. So we get negative 1.645. Okay, if the test were in the right tail, it would just be a positive 1.645. Okay, so for a one-tail test, it's either plus or minus 1.645. Now, if it were a two-tailed test, what I would need to do is I would need to take that 0.05 and divide it by 2, which would give me 0.025. And I would put that on either side of my normal curve. So I'd have 0.025 on the left and 0.025 on the right. In which case, then I would get that corresponding z value. I could go same thing. So second distribution, inverse norm, 0.025, 0, and 1. And that gives me negative 1.96. So this z value would be negative 1.96, and this z value would be positive 1.96. So my z-score here, I would just use the positive when I'm doing my calculations, 1.96. Okay, let's look at these errors. Remember, a type 1 error is going to be a false positive. Okay, so that is when the null hypothesis is true, but it is rejected. And a type 2 error is when the null hypothesis is false, but not rejected. Okay. And then this is your little chart here. So let's look at this again. So your rejection regions and non-rejection regions. So that has to do with our alphas, which is our significance level. So again, a two-tailed test, this is what we just did in our previous example. You have 0.05, you are going to divide that by 2, and you're going to put 0.025 on either side of your normal distribution curve. Okay, that was going to give you a z-score of negative 1.96 and positive 1.96. So this is the same problem that we did previously. This area here in the red on either side, okay, of my curve are my rejection regions. In the middle here is my non-rejection region. So this is my smiley face region. Okay, so if I were to draw a line here, if I have a critical value that is less than 1.96, I will reject. If I have a critical value that is greater than 1.96, I will reject. If I have a critical value that lies in between these values, I do not reject, which we say fail to reject. I know it is a weird wording. You could just say accept, right? But it's not, that's not how we say it. We say fail to reject. Okay, so let's say we want to do the same thing for a significance level of 0.01, and it's a left-tailed test, which means on the left side of my curve, I have an area of 0.01. So I want to find the z values. These are all z values that corresponds to this. So I go inverse norm, area to the left, 0.01, mean of 0, standard deviation of 1. So I get negative 2.326. Okay, which means that if I get a critical value less than negative 2.326, I will reject. If I get a critical value greater than negative 2.326, I will fail to reject. Okay, so we're going to do these with problems. You're going to be drawing a normal curve for each problem so you can visualize where that critical value is going to lie. If we were to do a right tail test, okay, so a right tail test, you would have 0.02 as an area. So this is 0.02. We want a z value for 0.02. So if I want the area to the left when I do inverse norm, I would just do 1 minus 0.02, which gives us 0.98. Okay, so inverse norm, 0.98, 0, and 1. I could alternatively also do just 0.02, know that it's on the right, and make the critical value positive, okay, because it's just the opposite value there. So you have both of those options. So this is a positive 2.054. Which means if I get a critical value that is greater than 2.054, I will reject. And less, I will fail to reject. Okay, so let's do an example of that. So a hypothesis test for a mean when a sigma is known. So when the population standard deviation is known. We can use normal distribution tables if population standard deviation is known and if the population is normally distributed. Okay, so our sample size greater than 30, population normally distributed, central limit theorem. All right, so here's the steps. So you're going to state the null and the alternative hypothesis. select this correct distribution, Z or T, Z when the population standard deviation is known, T when it's not. Determine the rejection region, okay, but that's what we just did. Calculate the test statistic based on the data. We have not done that yet, we will do that. Okay, then we will get the decision. Okay, so I like to graph it and look at it. See, is it in the region or not? You can also do it based off of the numbers. So if the p-value meaning the probability, is small, we're going to use this. So if p is less than alpha, reject. So if the p is low, the null must go. Okay. If the p is high, the null we fly. So if the probability is greater than the significance level, then you fail to reject. Let's do an example. Then you make your decision. Okay, so you guys can read this. You're testing to make a decision. You are not testing the alternative, but you just assume the alternative is true if you do the rejection. So let's look at an example. Okay, we're going to walk through this. So you have a null hypothesis is given to you that the mean is 25 of some value here. Okay, you have an alternative hypothesis that the mean is not equal to 25. So let's write that down. So the null hypothesis, mean equals 25. Alternative, mean does not equal 25. We have a sample size of 81. We have a sample mean of 28.5. We have a population standard deviation of 3. And we have a significance level of 0.01. Okay, that's what everything is given to us. First thing we do is find the critical value of the test statistic. So very first thing is determine if this is a two-tailed test or a one-tailed test. This is a two-tailed test because of the not equal to. So this is two-tail. So to get the significance level or the critical value, that's your z-score. Okay, and I know it's z because you have a population standard deviation. So critical value z of a two-tailed test, which means that I'm going to do 0.01 and I'm going to divide that by 2. That's going to be 0.005. I'm going to go ahead and start drawing that all the way down here. So I've got 0.005 on either side of my tail. Okay, let's find that z value that corresponds to 0.005. So I'm going to go inverse norm, 0.005, 0, and 1. So that's going to give me a negative 2.576. So I'm going to do plus or minus 2.576. I've got a negative on the left and a positive on the right. All right. So draw the critical region. I'm already working on that. And then we are going to do this. We're going to draw a rejection region. We're going to draw a smiley face. Oh, weird smiley face there. Hold on. For our fail to reject region, and then our rejection region. Okay, so reject, reject, which means what? It means that we will reject if we get a z value that is less than negative 2.576, or we get a z value that is greater than positive 2.576. All right, now we will calculate the test statistic, which means we are going to do based off of this sample. So now this is going all the way back to chapter 6, the test statistic for this information, which is z equals x bar minus the mean over the standard deviation of x bar. Remember, the standard deviation of x bar is the standard deviation over the square root of the sample size. Okay, so if I'm calculating a test statistic based off of this information, I'm going to go z equals x bar, which is 28.25. Sorry, not 25, 28.5, minus my mean, 25, over, let's see what this is, 3 over the square root of 81. I think that's 1/3. 3 over square root of 81. Yeah, 1/3. Okay, so 28.5 minus 25 divided by 0.3333 repeating. I get 10.5. Okay, so the test statistic is 10.5, which means it is over here. So then I evaluate my results. 10.5 is greater than 2.576, which means it's in the rejection region, so I will reject the null. And we're done. Okay, now you are going to get some problems where it's going to ask you to do a p comparison. When it is asking for a p comparison, it is asking you to find the probability of this problem here. Okay, so let's take a look at how you would do that. We'll use green here. Okay, so the p-value here is going to be given, okay, go back to, it's chapter 6? Yeah, chapter 6, again, the probability, 10.5, which means I do normal CDF, or I look it up in my z-table, okay, 10.5 to 99, because you're going, it's on the right side. So 10.5, 99, which should give you 0, if you look at that probability there. So second distribution, normal CDF, 10.5, upper limit, 99. Yeah, I get 0. So your p-value is 0. Your alpha, your significance level, okay, right up here, 0.01. Compare these. So 0 and 0.01. 0 is less than 0.01. So if your p is less than alpha, you will reject. It is the same decision. It's just based off of the value. So if p is less than alpha, reject. If p is greater than alpha, we don't reject. Okay, so that's the p-value decision part of it. I don't like it that way. Okay, I like to look at it and see it. But you will have to be able to do both. All right, let's do another example. Just one more, two more examples. Okay. Okay, so here you have, let's see, we have a null hypothesis that a mean is equal to 12. We have an alternative hypothesis that the mean is less than 12, which means that I am doing a left-tailed test because my alternative is pointing to the left. Okay, so I have a left-tailed test. I have a significance level, let's see here, 0.05. So I'm going to go ahead and draw this model here. So let's see, 0.05 on the left. And we do want a z-value because when I'm looking through all of this, I have a known population standard deviation. Okay, so let's get that z-value. We will go inverse norm. .05, 0, and 1. So that'll give us a negative 1.65. All right, so my critical value is negative 1.65. Okay, I've drawn my model. It is a left tail. And our rule. Okay, so my rejection region is going to be in the left tail. So anything to the left of negative 1.65. So I will reject if my critical value z is less than negative 1.65. So let's go ahead and find that. So we do this test statistic of our information here, which remember is z equals x bar minus the mean over the standard deviation of x bar. So let's go ahead and find the standard deviation of x bar first, which is going to be the standard deviation 4.5 over the square root of our sample size, 45. So 4.5 over the square root of 45 is 0.6708. Okay, so then we will do z equals our x bar 11.25 minus our mean 12 over 0.6708. Let's find that z value. So that's going to be negative 1.118. So we get a z value of negative 1.118. And then if I go ahead and I put this on my graph, that's about, I don't know, maybe right here. So that's in my non-rejection region. Okay, so if I do the comparison, negative 1.118 is actually greater than negative 1.65, which means I am going to choose the second option here. So we don't say accept the null hypothesis. We say we are going to fail to reject the null hypothesis. Okay, which is the same thing as accepting it. Okay, it's just not how we say it. Okay, if we want to go ahead and do the p-value real quickly for that, it is on the left of 0. So for the p-value, I would do normal CDF. This would be negative 99 because it's on the left. When it's on the left, we do negative for the lower limit, and then negative 1.118. So negative 99, negative 1.118. That gives me 0.132. Okay, our significance level was 0.05. We do the comparison. So P is greater than alpha, fail to reject. All right, how are we doing? All right, let's go ahead and do this last example here. So when I'm looking at this example here, I have, let's see, a null hypothesis of 40, an alternative hypothesis, the mean is greater than 40, sample size of 100, x bar of 47, population, standard deviation of 7, which means I'm using a z, and a significance level of 0.10. So let's state our information. So we have a null hypothesis that the mean is 40, and an alternative that the mean is greater than 40, which means this is a right-tailed test because the alternative is pointing towards the right. So let's find the critical value of this test statistic. If my significance level is 0.10, that means on the right side, my area, this area right here, is 0.10. So I want to get this z value, which is going to be inverse norm. And you have two options. You can do the 0.10 and then make it positive because you know it's on the right, or just do 1 minus 0.10, so 0.9001, because remember it's area to the left. So inverse norm, 0.90 and 1, that's going to be 1.28. Okay, so my z value is 1.28. We will reject if we're in the rejection region, which is greater than 1.28. So we will reject if our z is greater than 1.28. So let's go ahead and find our test statistics. So we'll start with the standard deviation of x bar, which will be given to us by the standard deviation of the population, 7, divided by the square root of our sample size, 100. So 7 divided by the square root of 100, 7 divided by 10, 0.7. Okay, then we will find the critical value here, z, which will be x bar minus the mean over the standard deviation of x bar. So 47 minus 40 over 0.7. So I think that should be 10. 47 minus 40 is 7. Divided by 0.7, we get 10. All right, so our critical value is way out here again, which means we reject. So our z is 10. 10 is greater than 1.28, which means we will reject the null. Okay, again, with the p-value approach, if I wanted to take the p-value approach, okay, you're going to find the p-value for 10, which it should be 0 again, because you would do normal CDF. 10, 99, that would give you 0. And then you would say your alpha is 0.10, your p is less than your alpha, which means you will reject the null. All right, so we are going to stop there. In 9.3, we're going to do the t values, critical values for hypothesis testing. So that'll be when your sigma is unknown.